So we're going to talk about how you integrate expressions like odd powers of these ones here. So if we had something like sine cubed, it's the solution really is going to lie in breaking it into pieces like this. Now, why might that be? Well, when you have, in fact, let's just keep the sine cube. When you have a trig piece with its derivative next to it, it's much easier than it first appears. If here you make sine x u, du dx equals cos x, and what you can do is you can do something like this. You can say, well, that's u cubed, cos x, dx. When you swap these bits around, what you'll do is you'll find that you get a result like this. And it actually simplifies quite nicely. So if you can get sort of just a single sine or a single cos on the outside on its own, the question would be much, much nicer than it looks. The problem is that we don't have that here. So we need to make that happen. And basically our strategy is going to be the following. We're going to write a sine or a cos on its own multiplied by sort of say something like a sine squared here or a sine to the power of 4 here, and that's going to be our way to make the same sort of situation happen. So sine cubed we're going to write as sine x times sine squared x, we said already. Because we've got this piece, we can use our identity. Our identity of sine squared plus cos squared is equivalent to 1, means that sine squared is the same as 1 minus cos squared. So if we put that result in now, we can say sine of x is multiplied by 1 minus cos squared x. And if we expand it out, we get sine x, which is quite easy to integrate, minus sine x cos squared x. Now, if I answer this one, for example, with u equal to sine x and du dx as equals, do I want to do that? No, sorry, I'll make this cos x. So if I do u as cos x and du dx as minus sine x, it's going to mean that I can do something quite nice with this one here. Okay, the sine I would just integrate without any substitution. So that one's just going to be minus cos x. I'll put the minus sign there. For this integral, the harder bit here, what that means is it's going to turn into, say, u squared. And in fact, if I borrow that minus there and make that a plus, yeah, the minus sine x will be taken care of on here. So this will turn just into u squared du. And in a nutshell, the whole integral will be a third cos cubed x plus c for that bit there. And if you just test it for yourself, you'll see that it works. The third and the 3 cancel each other out. The power goes down from a 3 to a 2. And cos differentiates to minus sine, which takes care of this one here. So we're going to do the next one. We're going to do sine to the power of 5. And we're going to kind of show that the same thing can be done there. So our strategy is going to be that we break it up into a 4 and a 1. We want to leave just 1 over. Let's do that now then. So sine to the power of 5, I'm going to rewrite as sine to the power of 4x times sine x. Sine to the power of 4 is a little bit more complicated, but on this one, if I square both sides, sine to the power of 4 is equal to 1 minus cos squared all squared, which is the same as 1 minus 2 cos squared plus, what's this one going to be? Plus 4 cos squared x. So this is the result that I'm going to be subbing in for my sine power of 4. So let's do that now. So we're going to do 1 minus 2 cos squared x plus, let's double check our work, that's the power of 4, plus, that's because I put the 4 in the wrong place, plus cos to the power of 4x, all times sine x. Hopefully you can kind of see where we're going with this. This times this is going to give us a sine x to integrate. The next bit is going to give us minus 2 cos squared x sine x. So we're going to get the same sort of thing that we had a minute ago. And then for the last one, it's also sort of the same. Okay, so sine integrated we've already done. It's going to be minus cos x. Let's see if we can do the next one sort of in our heads. We think that the sine is going to take care of the cos. Let's try cos to the power of 3x. Well, for the numbers, we'd keep the 2. We'd have a third. Well, how does this work? So cos differentiates down, that works there. The inside bit of the chain rule, cos becomes a minus sign. So that cos actually takes care of that minus sign. So I'm going to write that there with just a plus. I could have got the same result here by carefully doing a substitution. Let's try one more. Over here, cos to the 4. So let's try a fifth cos to the 5x. And let's just have a think about it. The outside, the 5 and the fifth works. Cos goes down a power to 4, so that's good. The inside, cos becomes minus sine. And at the moment, it's a plus. So would that work? No, that wouldn't work. That wouldn't take me back there. It would work, though, if I did it with a minus. So my final answer is, in fact, as follows. So if you have something like sine cubed or sine to the power of 5, the trick is to break it up and to leave just one of these here, because it will mean that you have a very easy first one. It will make any other ones much easier because the sine takes care of sort of the cos bit or the cos bit of the sine bit there.